Hi everyone and welcome to the new video. In my previous videos I explained how to use a Raspberry Pi, and it's a great device. It's a full-fledged Linux-based computer. It has plenty of GPIO ports and it can connect different interfaces. But there is another approach that is also fun to see, an ESP32. What is the main difference? Well, as we will see, there are several advantages. This is an ESP32 board. As we can see, it is much smaller, it is also cheaper, it consumes much less power. Now I'm connecting it to the power meter and the power consumption is about 10 times smaller than a Raspberry Pi. The Raspberry Pi is a hot device, I mean physically hot. New Raspberry Pi models mostly have active cooling. And compared to that, the ESP32 is much smaller, it's cheaper, it can be connected to your Wi-Fi at your home and work as a smart sensor. Raspberry Pi is also a full-fledged Linux computer, so it can be a source of the security risk. If someone gets access to the Raspberry Pi, it has a full access to your home network. Compared to that, an ESP32 is a bare metal project, it just has no OS inside. Nobody can do an SSH login to it because there is no SSH, it's easy. And it also has plenty of ports, we can do lots of things. We can connect GPIO, we can connect Wi-Fi, we can connect external devices. And in this series of videos I will show how to use the ESP32 in Python and C++. And maybe we will also try Rust as well. If you want to see it, write in the comments below. And don't forget to subscribe if you want to see more updates. And now let's get started. As the first part of this video, I will show how to use MicroPython on ESP32, and then we will use Arduino IDE and C++, but let's start with MicroPython. First we need to download it, obviously. If it's a new board, the MicroPython is not installed. MicroPython is a special version of Python designed for microcontrollers. At the time of making this video, the latest version is 1.27, but generally Python is compatible, so there should be no big difference for us. And as we can see, it supports a lot of boards and vendors. We obviously use ESP32, so we need to find our board in the list. As we can see, there are different versions of the ESP32, and I'm just selecting the standard one. I'm selecting the basic ESP32 version that I'm using. I'm copying this link here, and let's download it in the console. And now we can run the command and MicroPython will be installed. As an aside note, if you use the ESP32 with an Arduino or another system, you may need to make a factory reset first, you may need to erase the flash ROM. I will show how to do it from scratch. As we can see, I can erase the memory first and the board will be completely clean. And after then I can install MicroPython from scratch, so there will be no old files or corrupted data. I learned it practically when I used the board with an Arduino IDE, and later I installed MicroPython and I got a lot of errors like corrupted file system. For this project I will be using a Thonny IDE. It's a very simplistic one, but it's good enough for our task, so I will create a project and let's see how it works. Okay, I opened Thonny IDE. As we can see, it's a simple editor, a bit looks like Arduino IDE. We must be sure that in the settings ESP32 is selected. Our prompt should show MicroPython. It's actually connecting via the serial port, so my board is now connected. And our first ESP32 project will contain 3 parts. First I will show how to blink an LED, this is the simplest part. Then I will show how to connect the analog input to it. I will use a variable resistor for that. And third, I will use a pulse width modulation to change the brightness of another LED, so our analog input can be used to change the LED brightness. I will show it in different levels of simplicity. The first approach will be good for beginners, second approach is a bit for more advanced users, and third approach will use Asyncio. This is also for advanced users, so it can be fun. Let's get started. Our first task is to blink the LED. And the ESP32 board has on board LED with the pin number 2. First I need to import pin class from the machine. I will also use a delay, so I will import time. And on board LED has a number 2, so I'm creating a pin object. It's a class pin with a number 2. Those viewers who watched my previous video about Raspberry Pi know that the pin can be input or output. Here we configure the pin as an output, obviously, because we want to blink the LED. Our first approach will be very simple. I will have a while true loop. It's the infinite loop. And in this loop, I will set LED to true. Then I can set LED to off, and then I use a delay again. As we can see, the approach is simple. We can run the program and we can see that the LED is blinking. As a second step, I want to read the analog value within ESP32, and luckily for us, we don't need an external hardware for that. We only need this variable resistor, and we can connect it directly to the ESP32. The connection diagram is simple. One pin is connected to the ground, another pin is connected to the power, and the ESP32 has already special module. It's called analog to digital converter. First, I am using a DC read 16 method, and read 16 means that it's a 2-byte value, it's a 16-bit value. I can also use print here so we can see the values. It's good for debugging, and now I'm just running the project. And when I rotate the variable resistor, the amount is changing. As we can see, I am using read U16 method. U16 means unsigned 16 bits. As we know, 16-bit value can be from 0 to 65535. So when my resistor is in the right position, we get the value 65535. And when I rotate the knob, value changing from maximum to minimum. As a next step, let's use a second LED. I will use it in the so-called pulse width modulation mode, so we can adjust its brightness. As we can see, the logic here is simple. We can see a frequency and we can see a duty cycle. For example, we can vary it from 0 to maximum and the amount will be changed. The frequency is high and we cannot see it with the naked eye. And luckily for us, the ESP32 is doing all calculation. I only need to add the PWM pin. As we can see here, I'm using pin 4 and we can control the LED with the analog knob. Let's see how it works. Of course, I need to import PWM, otherwise it will not work. Let's restart again. And as we can see, the code works. We can adjust the brightness from 0 to maximum. And now I can remove this print. We don't need it anymore. So this code works, but we can make it better. As we can see, I want to use this LED as a heartbeat, so it's blinking once per second. But it means that we block the thread and we can read the values only after 2 seconds. So when I rotate the knob, there is a visible delay in the brightness. Let's fix this. To do this, I will use a timer. This is also an important concept on the ESP32. Timers here are a bit different compared to the classical Python timer. But its logic is easy. I can add a method on timer. So we will read and write value immediately. And now at the start of my app, I am creating the timer and the interval is 1000 milliseconds, so it's 1 second. And as a callback function, I will call on timer, so the LED will be changed from 0 to 1 and back. Let's see how it works. As we can see, it works much better now and there is no visible delay. Of course, analog to digital converter has some internal delay, but it's very small, it's not visible. And the timer is triggered every second, so we can see that our heartbeat LED works correctly. So this part works. Now let's go to the more advanced part. In the previous code, I used the timer to blink the LED. This approach works. However, there is a different approach. We can use Asyncio, which is a very powerful tool for async programming. Nowadays, it is widely used in systems like Android and also in the desktop Python. The idea of Asyncio is that it is a lightweight thread. All code is physically executing on the same kernel, but we can run many tasks in parallel. Python is just switching the context. This is a very powerful approach for the desktop, for example, for the web server that can handle hundreds of connections, because we don't have a CPU with 100 of cores. And of course, it is important for the ESP32 because technically ESP32 has 1 or 2 cores maximum, so we can do many tasks. And in my previous code I used the hardware timer, but with Asyncio we don't need it, so let's see how it works. First I'm importing Asyncio, and I will create a method to blink the LED. As we can see, this code is simple. I have a while true loop, but there is a crucial difference. I am using Asyncio sleep, and there is an await keyword. It allows Python to switch context to another task, so several tasks can run in parallel. And now I will create a main function. Here I am creating a task. Our period is 1 second as before. And this main function has another infinite loop where I read and write my ADC values. So I read the value from the ADC and I write it to the LED. The general logic is the same as before, but as we can see, the syntax is different. Last but not least, we will start this method using the Asyncio run. Now I'm running the code, and as we can see, the LED works. I must admit that the Asyncio is a complicated thing to understand. There are many nuances that can be hard to understand. For example, if I will use standard sleep like this instead of Asyncio sleep, everything will be broken because we must not block the main thread. And in Asyncio it's crucial because otherwise all magic will be broken. And there are also lots of libraries that use classical Python code, not Asyncio code like this. So if we are using Asyncio code, all our methods should be Asyncio compatible. They should not block the thread. They should not use standard sleep or something like this. So Asyncio programming can be a bit complicated, but it's an interesting approach. And it is especially effective on the ESP32 because technically ESP32 is like one core processor. And of course here I actually use two tasks. One task is to read and write analog values, and the second task is to use the heartbeat. But of course in reality Asyncio is much more powerful. We can create a lot of tasks and they will share the same thread. So technically it's a very interesting approach and it's nice to see how it works. And now as a last task, let's try C++ and Arduino IDE. Okay, as a bonus for the viewers who are patient enough to view until this point, I will show how to program the ESP32 in C++ in the Arduino IDE. Here we'll be using C++, which has important advantage. It works much faster because it is a compiled code. For example, in my previous project I was using Bluetooth audio, and MicroPython was just not fast enough to support this. And it is also interesting to see how it works. Arduino is a popular tool for lots of hobbyists and for lots of projects, so let's see how it works. Let's get started. The general idea will be a bit similar to Asyncio, so I will not be blocking the main thread. First, let's define constants for our pins. The first important method in the Arduino IDE is called setup. And here, as we can see, it is simple. I initialize the serial port so we can see how up works. It's good for debugging. And I also configure two pins as outputs. The second important method is called loop, and as the name suggests, it's called automatically by Arduino. As a first simple approach, let's just blink the LEDs. As we can see, the logic is similar to the Python code. We set pin to high and to low, and we have a delay to 1000 milliseconds or to 1 second. And then you can compile the code and it will be automatically uploaded to the ESP32. To enable ESP32 support, I need to install these libraries. They are already installed, as we can see. Okay, the code works, LED is blinking. As a next step, I can create a software timer. First, I will add some variables. Here is the timer interval, that is 1000 milliseconds. The same way as in Asyncio, I don't want to block the thread, and I will remember the LED state. If the LED state is low, I will set it to high, and in the opposite state, if the LED state is high, I will set it to low. So I can remove this code, I don't need it anymore. And the logic here is actually simple. There is a method millis in the Arduino code, and I can use it like this. And this way the timer will be executed every second. That is what we need. And as we can see, the LED is blinking. This part works. By the way, attentive viewers may think what will happen if the millisecond run will be higher than unsigned ESP32. I can give it to viewers in the homework, write the answer in the comments below. It is actually interesting. As we can see, the logic here is simple, but what will happen if this value will reach the maximum? I will give it as a homework for viewers and we will go forward. Our last step is simple. I can read the value from the analog to digital converter from the IDC and I can write it to our LED. The interesting part here that the analog read function in the Arduino IDE returns the values up to 2065, and analog write here has a different range, so I need to adjust these values. Let's run the code and see how it works. And I can change the resistor and I can see that the LED is also changing. Our code works. Okay, that's it for this video. Thanks for watching. I hope you learned something new. In the next video, I will explain more about ESP32, how to run your own web server, how to connect to Wi-Fi, how to send and receive MQTT messages. The source code for this project is available on my Patreon page. Feel free to visit it if you want, and this support also helps me to buy different hardware for testing like this. Also, press like and subscribe if you like this video. Thanks for watching and see you next time.